Today is like it's been very long time since I didn't make any system design video, and so today we're coming today with a new system design video, which will be design WhatsApp. So if you don't know WhatsApp is a chat application that we can handle one-to-one application, one-to-one chat, and also group chats. Um, so when you start with a system design interview, we should have a plan. So the plan comes to have, let's say we have four steps. The first one, it will be that we ask for clarification. The second is that we propose a high level design. Propose high level design. And the third, after you propose a high level design, your interviewer will ask you to get deep dive into specific components. Deep dive in specific components. In deep dive, let's just call it deep dive. And after that, we have wrap up. And inside the wrap up, we will just talk about how to improve the design. So this is the framework that we are going to use when we're trying to succeed in our system design interview. So first of all, we have design WhatsApp. I highly recommend you to ask your interviewer what is WhatsApp. If you don't know what is WhatsApp, just ask your interviewer, and it give you a clear idea what is WhatsApp. For example, if what's TikTok, what's Twitch, and if you don't know what this application is, just ask your interviewer about it. So after you know what this application is, we ask for clarification questions because of course WhatsApp is a massive application. We can design everything about WhatsApp, so we need to ask for clarification questions to make sure that we design the exact same thing that our interviewer wants us to design. So we have these type of questions. We have about like 1, 2, 3, 4, 5, 6, and 7. Maybe you want to make from 5 to 10. So from this questions, we want to know how scale our application. What is do we prefer the availability or the consistency for application? What other functionality in the application? What are the non-functional requirements of the application? So the first question, let's just start with it. It will be what kind of chat app shall we design? And the answer is true. It we have one-on-one and group chat. We support both the one-on-one and group chat. And the other question will be, is it post for mobile app and web app? And this make difference because we have to calculate this functionality. And the answer will be yes, it is for both. So we ask another question, which will be for the group app, what is the group member limit? And for the group member limit should be max 1000, and this is a lot because if it was like 500 or 300, that means that we can get away with basic solutions. But for this 1000, we have to think about the scalability of the groups. And the other question will be, okay, what are the features important for the app? So right now we want to ask to know what we're designing exactly. So we have one-to-one chat, group chat, online indicators, and we only take about text messages. There is no image for this one. We can create another video talk about how we can handle the image. So do we have any limit size for the message? And the message is 100,000 characters long, and is end-to-end encryption required? And thank God it's no, because if it's yes, it will be a lot to do in one video. And how long should we store the chat history, and should be forever? So from these questions, from these clarification questions, we know we know our requirements. So our requirements maybe will become to 6 or 7 requirements. So we have one-to-one chat with low latency, small group chats of max 1000, sorry, group chat with 1000. Online, we have online presence. It's quite important. Multiple device supports the same account can be logged in. That means the same account can be logged in multiple accounts at the same time. We have a push notification, and also we have okay, the EU. It's important. It's really important. To this could be the one. The sorry. This could be. Oh, sorry. This could be the eighth questions that we ask about how many daily active users do we have. Ask this question each time. How many daily active user we have? So it will be 50 million. Okay. So these are the requirements. So let's just start in proposing the high level design. So first of all, let's just start simple, and after that we could make it complicated as much as we want. So let's say that we have user one. Let's make it white. Let's say we have user one, and let's just make this one quite really small. And user one, and let's say that we have and we have user two. Okay, let's make this one white. So we want to make sure that both of them are connected to each other. They are sending messages to each other. So there's maybe like three ways to do it. That we can just do something called a pooling. That means user one will try to connect with user two and try to send messages maybe like every 10 seconds to make sure to know if there is a new message or not. And this could cause a lot of problems because we will send a lot of unnecessary requests. There is other solution called long pooling, and this one is that we will send a request and we will fill a little bit time to get a response from the user two or not. And this is quite better, but just also it's not ideal for our system. What I guess it will be better idea is to use something called a web server, and the web server it's using a TCP protocol. It's bi-directional way to communicate with the servers. So, for example, that we have user one and user two, and let's just create another one here. I want to make it white and wider and make it, and we have a chat server, and this chat server is the connecting with using a web server. No, back. Yeah, and also with this one. Okay, so they are connecting using a chat server, and the chat server stores the messages and send the messages to the user one and user two. And by using the WebSocket, that means that we make sure that we have a directional communication. That means whenever user one sends a message, it will be directly to user two. Whenever user two sends the message, it will be sent to the chat server, and the chat server will send it directly to the user. So there is no need to make any unnecessary API requests, and this is way more reliable. So right now we have user one and user two. So let's just talk about, let's say that we have multiple user, and this we can't have one chat server is not enough. So maybe we could create multiple chat servers. So let's just oh sorry, let's go back, delete this one, and let's just create multiple chat servers, and let's just make them aligned with each other, and we maybe they will connect with using like the users will connect using like a load balancer. Let's just make it like there's no need to have a big space. This will be a load balancer, or like let's say the API gateway just will distribute the. Okay, I wanted to make it. Okay, and let's just make another one here for this one, and another one here for this one. So let's right now we are have distributed and we have multiple servers, and in the chat servers we had which would have a push notifications. So like it will be a third party, and this third party will be a push notification because we need to when any one of the users get a new message, and maybe it's not offline, or maybe a new message, and it needs to know that yeah that you have a new message or something like that. So we have a push notification, and let's just make this one way more like that. So let's just okay. So okay. So let's just talk about what we have here. So the um this this application right now. So the chat servers physically we have oh okay, because before I talk about it, we have right now the chat server. I guess we should store our own messages in a specific store, and I guess it will be a good idea about to store it in let's say, let's say for now we will store it in 1 minute. We'll store our messages in a key value store. Okay, let's just make it a key value store. So it will be NoSQL, and we will talk about why NoSQL and why we're using the and why we talk about the data model. But let's just make a quick recap right now. So we have first of all we have user one and user two. They are connected with the load balancer, and the load balancer distributed all of the requests across multiple chat servers. The chat service is handling the receive and sending functionality, and also the chat service has two important things. It has the chat servers, and it has the presence servers, and this is for the online and offline, and we will talk about that. And the notification server send the push notifications if we because we will need it. And finally we use a key value store to store the chat history when an user is offline, and we will store it in so when the user is offline we can fetch the chat from it, or maybe if user request the old chat we can fetch it from it. So let's just talk about the database right now. So at this point, we have servers ready. We have 50 million daily active users, and we have a third party push notification running, and everything looks fine, and we have everything looks great. So right now we just want to care about how we will handle the storage and what should we use. So we have SQL or NoSQL database for this example, and I guess it will be good idea to go with the NoSQL, because when we deal with the chat, it's that we have massive data, because I guess Messenger or in Facebook just reported that they have, I guess, 10 billion message a day. So we talk about tons of data, and we will work with sharding, and we want something that easy to scale out. So I guess it's NoSQL will be a great solution for that. We could use Cassandra, or yeah, you could use Cassandra as our NoSQL, because it's I guess based on our requirements it will be a better solution. And before I continue the system design, I just want to say something, that when we have something to choose from, like for example, I'm saying NoSQL and SQL. So I will just, you has to ask for clarifications and you ask for permissions when you talk with the interviewer. So I'm saying right now, NoSQL is good because one, two, three, and and I will choose it. Is it okay for you, or just we need to have be a SQL database? you need to ask your interviewer like all the time about clarifications all the time. So let's say that yeah, and we said that we use a NoSQL. Maybe we could use this Cassandra. We could use HBase, whatever it will be. And this we talk about what type of uh, of database that we use. Right now I want to talk about just can I delete this? Yes. I want to talk about the data model. So let's just create a table. I want a table. Okay, let's just take this table. Use template. And I want to delete actually this one. Delete and delete and have it like that. And we have for this one I guess we could use 3 or 2. Let's go with 2 tables. So we will have the message table. This will be the message table, I guess. The message table, and just make this one bigger. Okay, and the message table, it will be oh no, let's go back. The message, we will have a message. It will have a message ID. Oh, it's too small. Let's make it smaller. Yeah, will be a message ID. Let's call it a message ID, and I guess this will be an integer. And we will have message from. Why it's not white? It will be. Oh, I don't like Miro for that. It will be message from. Fuck. Sorry for that, but just this annoys me all the time. Message from. And this one will be also an integer. And this will be, I guess, the ID of the user. Oh. I want to make this white. Can you just make it like all of it should be white? And we will have maybe, I guess we'll have message 2 also. 2, and this will be I guess this will be also an integer because it will be a same ID. And maybe we have the of course we have the content, or like text. Let's call it content, and will be string or text. Let's call it text. And maybe we'll add another row. And I guess for this one it will be quite important that we have a created it, and this will be date timestamp, or like time stamp. And I guess this is a table for the message, and I guess the table for the group, it will be quite similar, because I guess we need another table for the group. Let's just have this one for the group. And I guess what will be different with the group, it will be we will have a channel ID. Maybe we have something called, we call it channel ID, and this will be maybe the group ID, and this will be also an integer. And maybe we have the message ID, that will be the same, and we will have the user ID. Maybe we have 2 4. This is, I guess we'll have maybe like user ID, and this will be an integer. And I guess we will still have the content at the created it. This is what I'm thinking about. But it's quite important to talk about the. I want to talk about the message ID because it's quite important to talk about message ID because we will have tons and tons of messages, and we want to make sure that the message ID will be quite unique. So in terms of the message ID, we could increase the message ID by date, and we could use. I think that we could use the Twitter solution, the something called the snowflake. So that means I will do actually a specific video about how to generate a system that generates ID about it. But like for this for it doesn't I don't have to get deep into it. I just say for the ID I will use the Twitter snowflake because it's the most optimal solution, and because we wanna increase the ID by time, and yeah, because increasing the ID by time will help us into the into getting the offline and the online. So right now, I guess we are done with the high level design, and I guess that we could take a deep dive. Your interviewer will ask you take a deep dive into specific concepts, and I guess that what could you ask you about is that we could work with the service discovery, which will be the service discovery, which will be it's a pretty straightforward. The service discovery. Let's say that I want to make one here, and I want to make it dot. Uh, just no. How I change the border? Um, okay, let's make it. Okay, let's. I'll keep it white. I'll keep it white. So let's just make it white from here and white from here, and just okay. So um okay. So basically the service discovery that we need to when the user is connecting with the load balancer and the or distributing the chat server, we need to find the perfect server for the user to connect with. So we can use something called Apache Zookeeper, and this is a popular open source solution for service discovery because we want to discover the best server to for the user to connect with. So this will be called Apache Zookeeper. Let's call Zookeeper, and I want to give it a color. So Zookeeper will be service discovery that will choose us a perfect server for the user to connect with, and this is also it's like based on it's the user geographics, like the user position, where is the user in. So right now, the user will when the user logs in and will try to communicate with the load balancer. It will go with the zookeeper. The zookeeper will choose the perfect chat server for him, and after that we will have the chat servers, and we'll have the presence the present server that makes it sure that is the user online or not. And I guess, and also we can work with, we have a push notification for the server, and after that we have the key value store, and we talk about that we use a NoSQL database to make sure that because we need the scalable, and we need database to be easy to scale out, scale up, scale out basically. And there's nothing called scale up. Sorry for that. And we talked about how we will module our data, and it's quite important also to ask for clarifications after each step. So right now, I guess we could talk about like maybe there are two more aspects. One of them is the message flow. So how the message flow works? So the message flow works like that. So we have the user one, okay, is connecting is sending the requests to the chat server, to the operator, to the chat server, and after that this chat server send the the um, the chat server to push notification, for example message queue. And for the message queue, sort the values in the key value store, and maybe when a user B is online, we will send back uh, we will send when user 2 is online, we will send the message to user 2, If user 2 is offline, we make a push notification is to send the it will send from the push notification. So that's it, how the message flow works. And maybe we could talk about two important things about how we can handle the multiple how we can handle, just 1 minute. Let's think that we can have multiple devices. So let's say that the user have a mobile, user one, mobile, and let's just say that, and user one also desktop, and let's just make these together, and we have the chat server, and this will be in between, and both of them will connect with the chat server, and I need to make it like that. And the chat server, let's say that for simplicity right now, the chat server will connect with the key value store. Okay, so right now, maybe the when the user in mobile just have a message and it read the message, the user one, the same application, the open desktop should know that this message has been read. So we'll use something so called a variable called current um, max message, and this one will use it to know what are the for example, is like it will be a random number. For example, this will be, so for this one what we are going to talk about that um we have each device of these two things is has a variable called current message ID, and the current max message or current max message ID, which keeps track of the latest message ID on the device. The messages that satisfy the two following things are considered as new. The recipient ID is equal to the current logged in user, because each recipient has its own ID. The message ID in the key value store is larger than the current max ID. So that's the way that we can handle the two devices in the same time, or you can just add four, three. It doesn't matter. So after that, we want to talk about how we will handle the small group chat, because our group chat will be quite small. So to handle the small group chat is that, let's say that we have user one, and let's say that we have user. Let's delete this one. I don't like that sometimes when I try to copy some things, it doesn't work. User 2, and let's say that we have user 3. Okay, here. So this is user 2, and this is 3, and this is 1. And let's say that we are in a group chat. So basically, user 1 will send a message to a chat server, and let's just make this one smaller, and it will be in between. Yeah. Okay. So basically, user one will send the messages to the chat server, and the chat server will say will send the messages to the message queue. Let's say that each one of them. Sorry. Oh, delete this and go back. Yeah. So have a message queue. And let's just make this one smaller, and it will send it to this message queue, and the message queue will send the message to user one, and also it will send another message to another message queue. Sorry. And let's just I don't know why they make this one by themselves. I don't like that. And the message queue will send the request to the user 3, and this could work perfectly fine. But however, the for it's a quite simple, it's quite easy. But to create a message queue for each user, this is we will go out of resources and it will be quite hard. But this solution actually is we should using it, and it just limit the the groups was to 500 or like 1000. So this is a good one for good solutions for the small applications. However, for groups with a lot of users, sorting a message copy for each member, because we are sorting the message copy for each member in the message queue, is not acceptable. But this is good for small groups. So that I guess our group is 1000, so it's just quite small. It's not big. We don't have hundreds of thousands. So each right now we in the reception also, the reception will be the same. So if user 2 and user 3 send messages, will be sent to the chat server, the message queue, and also will be sent to user 1. So I guess right now we could talk about how we know if the user is online or not. So to know if the user online or not, that we can use for example, let's just say that we have this user and the user is connected with the chat oh sorry, will connect with the chat server, but it will specifically will connect with a pre-scene servers, pre-scene server, and the pre-scene is also connected with using a WebSocket, and the pre-scene server is connected with a key value store. And what we're going to do here, just to make so it's too big. And what is going on in that when the user logged in, it sends to the in the server discovery, after WebSocket connection is built between the client and the real-time servers service. This user basically its status and the last time active timestamp are saved in a key value store, and in the presence indicator shows the user is online or not based on the logs. And also when we have logged out, it will happen the same. So let's just have in the logout, if user will logged out, it will be like user, and maybe we have like an API server in between, like for example that we have like API server in between to handle the logging out, and after that they will send a message to the they will send like a notification to the presence server, and we handle the presence server updates the key value store. However, we have something different, which will be the user disconnection, because users actually used to do a lot of connection and disconnections, and we can do something that whenever the user is connected and disconnected, we can just send the user will send a request to the server, and we'll make sure the server tells the server, hey, I'm logged in just to change my store. And this could work, but we have a problem that we have a daily 50 million active users. So the problem with that is that users used to go in and out a lot. They used to go online and offline a lot, and they use it to disconnect. So a good solution for this one, because if we did just like that, I guess we maybe will fear we will make our server will be overwhelmed from the amount of the requests that will be sent. So a good solution, in my opinion, it will be that let's say that we have the user, and we will have in the presence server this one. Let's just take this one. Let's just copy this, and let's just go back and delete this and copy this here. So if in the let's just go this one and just make this bigger and bigger. Okay, so let's say this is in the, okay, it's too big, so let's just make it smaller. No. Okay, this is I guess this is acceptable. So what we can do is that we can use a pops up solution. So what we're going to do is that we will have a message queue. A message queue, and we want to make yeah, and we want to make this one quite smaller. And let's say that we have, let's say that we have 3. Yeah, I don't like. Yes, okay, let's just make this one in the middle and copy it. And copy it, please copy it, right. I like sometimes this application, this and paste. How can I do paste? Anyway, Control V. Oh, finally, Control V. So, and let's just make the pre-scene service quite smaller, and let's just make this that, like that. Okay, like that. Okay, and okay, so we have, okay, oh, okay. So for this one, I guess this solution would be quite way more better to talk about the connection and disconnection, and this is called the fan out status. So how do the users, for example, how does user friends know the about the status changes? For this from this um, design that we put, it explains how it works. The pre-seen service uses a publish subscribe model in which each friend pair maintains a channel. When users, for them, this user is online status change, it publish the event to 3 channels, the channel A, B, C, D. For example, 4 channels, these 4 channels, not 3, sorry. And let's just call them A, B, C, D. And those 4 channels are subscribed by, for example, let's say that we have, let's say that we have user 2, and we have, just copy this one, and user 3, and user 4. So, oh, let's just create another one. I don't know why they make it like that all the time, because I never asked to me. Okay, so we have these 4 users. So the 3 channels are the 4 channels right now are for the 3 objects. Let's make it 3 channels. Let's just delete this one because there is no need. So let's say we have 3 channels are for the 3 users, and each one of them can access the status quite easily. However, you should know that above if solution is effective for user group, for small user group. This one is effective for small user group. We should also, I guess, use a similar approach, because its user group is, I guess, 600 or 800. For largest group, information all members about online status is expensive and the time consuming. So assume that if the group have 100,000 members, each status change will generate 100,000 events. To solve this performance bottleneck, a possible solution to fix that is to fetch online status only when the user enters a group. And yeah, that's it. So I guess that right now we finished everything, and we wanna if we wanted to wrap everything up, that right now we talked about how to design WhatsApp, and we talk about we're using this framework to make sure that we are getting succeeded in our system design. So right now we ask about clarifications, and after that we propose a high level design, and after that we went to deep dive, and right now we are go doing the wrap up. So in the clarifications questions that we ask about, like from 5 to 7 or 8 questions, to make sure that we understand the problem or not. So and the goal is to understand what specifically are we design, what is the scale, what is the requirements, what are the function requirements and the function requirements, and also we understand what type of system in terms of the cap theorem, what type of system are we designing here. So we from the questions we get the requirements, and it's quite important to ask after we do the requirements, ask your interviewer, is this okay, or do I have to eat more? And after doing the requirements, we propose a high level design. In the high level design, we talk about how the user one, user two will connect with the load balancer, and we will send it to the chat server. Zookeeper will be used to direct the user to the closest chat server next to the user one. And we have a push notification, and we store the messages in the key value store. And after that, we talk about the modeling of the messages in the key value store, the messages in the group. And after that, we talked about how we can support multiple devices. And after that, we talked about how can we support the online and offline status. And after that, in the end, we talk about how we can handle um, the um, the connection and disconnection problem. So I guess it was a long video. So if you watch it until now, so that's good. I love that. Thank you for watching this video. And if you like my solution, and if you like my content, make sure to subscribe and hit the notification bell so you'll never miss a video. If you don't like my solution, make sure to give me feedback about what you didn't like specifically, so I can improve it and I will never do it again. So that's it for this video, and see you in future problems.